Hello everyone, I'm Pietro and today I'm going to present this working paper analyzing municipal solid waste management in Italy, a machine learning approach to identifying key drivers. This is a three authors paper with Professor Lombardi, Colivicchi and me. So we can start. We focus on this sector for two main reasons. First, United Nations Environmental Programme made a prediction of total world waste production, stating that by 2050 the number will reach 3.88 billion tons. And second, the UE directive of 2018 sets a target for European countries of a recycling rate over 55% by 2025. Italy already met this target in 2023, but there are still depth disparities between the north and the south in terms of differentiation rate. For these reasons, we focus our analysis at the municipal level. Regarding the gaps in the literature, we find that many studies use linear models, which fail to capture the non-linear trends of waste-related variables. Furthermore, few studies integrated granular municipal level data with cost of capital, collection method, and socioeconomic and demographic variables. Our main research objectives are first, to identify the key drivers of waste differentiation efficiency across Italian municipalities, and second, to quantify the role of collection methods, socioeconomic and demographic factors. To do this, we apply two methods: MERF, Mixed Effect Random Forest, for the regression part, which is designed for panel data and captures the heterogeneous national context we are dealing with, and Shape Framework to interpret and analyze the machine learning black box. So we have a panel dataset of 1,706 municipalities over 6 years, from 2017 to 2022. For how to concern the data, we use several public sources: ISPRA Cadastre for waste data, AIDA for utility financials, and ISTAT, MEF, and MISE for the independent variables, socioeconomic and demographic ones. We also use company website to collect the collection method used by aggregated municipalities. So at the end, we have our target waste differentiation rate and these following independent variable: cost of capital, collection method, socioeconomic like income, age, secondary and tertiary education, and geographic like location, area in square kilometer, and density. Then we run our regression model and obtain good performance. The model converges via the generalized log likelihood after about 5 iterations. We calibrated it with 5-fold cross-validation and grid search, obtaining these following best hyperparameters: 153s, depth equals 6, and max features equal 4. Our training set covers the first 4 years of our panel data, and the test set the last 2 years. We obtained a test mean square error of about 0.59% and an R square of 0.79. At this point, we move to the shape framework and feature importance analysis. In the plot on the left, we can see the impact of each feature on our target variable. In this presentation, We'll go through the top 4 drivers plus cost of capital for inhabitant, which is a very important driver for policy and investment implications and recommendations. Looking at the left, we can see the population density partial dependence plot. The differentiation rate rises from 45% in sparsely populated areas up to a maximum of 71%, which corresponds to the inflection point at 191 inhabitants per square kilometer. And at this point, we reach the peak of economies of scale, after which the trend decreased slightly and stabilized around 1,150 inhabitants per square kilometer. Moving on the right side, you can see the door-to-door collection variable. We find a consistently positive effect, up to a plus 15%. This method outperforms proximity-based and hybrid collection systems, which show lower feature importance. However, there is a great trade-off with higher service costs, since door-to-door collection requires higher investment in fixed assets to manage its specific processes. Moving to the other features, we see a sinusoidal partial dependence plot for average age. It reaches a maximum of about 71% for people younger than 44 years, then decreases down to 60% for people older than 51 years. This is linked to younger people feeling a stronger impact from the Ronchi decree, which introduced stricter waste sorting duties and promotes environmentally friendly behavior within a more circular economy framework. In the center, we can look the average income as a positive effect. We see up to plus 5% when income is higher. So, in larger cities with higher income, we tend to see better differentiation efficiency. This is linked to greener spending habits among wealthier people and lower in-home consumption. In this sense, average income can be seen as a proxy for environmental awareness. Moving on the right side, we see the cost of capital per inhabitant. We see a positive monotonic trend. Higher investment in fixed assets is associated with better differentiation rates. This variable reflects a utility's capacity to adopt sustainable collection and transport methods, driven by greater supply chain digitalization and the use of green and zero-emission vehicles. This is a key variable for investment recommendations, both for policymakers and utilities themselves. To conclude, waste management performance is multifaceted. The sector is shaped by internal drivers such as collection method, capital investment, and by external factors such as demographic and geography variables that utilities cannot control directly. For this reason, an integrated and cross-cutting policy analysis is needed, along with coordinated recommendations for policymakers. So, to conclude, our results confirm that MERF combined with SHEP framework outperforms traditional linear models when dealing with heterogeneous panel data like ours. Among the drivers, door-to-door collection is the primary controllable lever, with a plus 15% of the impact on the differentiation rate. We also identified a density threshold at 191 inhabitants per square kilometer, beyond which the agglomeration benefits start to reverse. Age emerged as a key social drag, while income acts as an enabler. Finally, cost of capital confirms that utility investment in fixed assets is directly linked to better recycling outcomes. Looking ahead, we see three main directions for further research. First, we want to promote a deeper analysis of collection method through a causal model like diff in diff to move beyond correlation and better isolate its real effect. Second, we plan further research on age structure and its impact on sorting behavior. And last, we aim to analyze the innovative logistics needed in sparse and wide area municipalities where standard collection methods are harder to apply efficiently. So, thank you for your attention, and I'm here for your questions.